Now we take example of a 4 variable function which will be implemented using K-map. So suppose the given function is f a b c d. So these are representing your variables, and here there should be representation of sum or pi value, which is representing that if the summation sign is there, it is representing that the given values are minterms. So these are different minterms available for this given boolean function. So now first the number of variables are 4. So total number of required squares will be 2 power 4, it will be 16. So this is similar to the number of different combinations that can be made using 4 variables. So suppose we are using 4 different variables a, b, c, d. The numbers can be starting from all 0. It can be suppose 0, 0, 0, 1. It can be up to 1, 1, 1, 1. So the first number is your minterm m0 and the last number is representing minterm m15. So there are total 16 number of minterms. The same value is here because in K-map we are representing each minterm value. So first we will start with representing 4 variable K-map. So since there should be 16 number of squares available, so first we will divide this box into 16 different squares. They're not exactly square in my case, but it should be square. So we will take 2 variable here. It will be suppose AB, the third is CD. We assume that here A is representing your most significant bit and D is representing your least significant bit. So value of AB can be 0, 0, 0, 1, it will be 1, 1 and it will be 1, 0. I told in earlier video that this number system is generally utilizing gray code values. So here 0, 0 means it is representing A dash B dash, it is A dash B, it is AB, and the last one is AB dash. Similarly for CD it is 0, 0, 0, 1, 1, 1 and 1, 0. This 0, 0 is representing C dash D dash, this is C dash D, it is CD, and the last one is CD dash. Now before starting placing these values in these boxes, we should be careful about the minterms location. So this minterm value is simply it is m0, this value is m1, this is m2 and this is m3. M3 why? Because we can see that for this case this value is 0, 0, this value is 1, 1. So 0, 0, 1, 1, it is representing your m3 value. So if there will be 0, 0, 1, 1, 0, 0, 1, 0, it is representing m2, it is representing m3. Similarly next will be your m4, m5, m6 and m7. The last it will be m8, m9, m10, m11, m12, m13, m14 and m15. So you can see that if you're talking about this m14, so for this case it is 1, 0, it is 1, 1. So when we are having 1, 0, 1, 1, it is exactly denoting your m11. So we can take base of m10. Suppose we are taking m10, it is 10, 10, 1, 0, 1, 0. See here it is m10, 1, 0, it is 1, 0. So now we have identified the minterms requirement here. Now see the values here, it is 3, 5, 7. So we will write 1 whenever we are encountering that minterm values, 1 at place of 3, 5, next 7, next it will be at m8 location, m9 location, m13 location and m15 location. So since it is summation term here, they are representing m3, m5, m7, m8, m9, m13 and m15. Now once you have placed high values or 1 values in these minterms location where it is already defined in your function, we have to make group of, or we have to make pair of ones. Either the pair will be of in the form of 2 power 0, 2 power 1, 2 power 2, 2 power 3 means pair can be of single term, it can be of 2 different ones, 4 or 8. So we have to first see the maximum range of pair that can be formed, or the maximum number of ones that can be formed to make a group. Here we can see that these 4 ones, they are forming a single group. Now again if we want to pair, so this one is remaining, so it is suggested to make this one pair with its adjacent one, although it is already involved in one pair, but we will make it so that it will be minimizing this function. Again, in this case, these two terms are making a pair. So now at this situation, we have to see which terms are common for this part. So when we are pairing this 1 and 1, you can see that for both the midterm M8 and M9, AB dash is common. So we will write here AB dash. So from the row side, it is clear that AB dash is common. For M8 and M9, we can see that here it is C dash, here it is C dash, but for this case it is D dash and it is D. So for M8 and M9, only C dash is common, so it will be AB dash and C dash. One part is done. For this case, if we are representing this form, so here we can see that CD both are 1 1, so CD is common for this one and this one, and from this side your A dash is common, so it will be A dash C D. The last final term is this one. The last term is 4 1, they form a square here. So here the value is A dash B, it is AB, so B is common for this part, and next for this part your D is common, so it is representing your BD term. So the final function will be here. The final function will be represented as A dash CD plus BD plus AB dash C dash. So the order is not important, whether we are writing first AB dash C dash or we are writing BD first. The part is the minimized function is required. So if we have started with 1, 2, 3, 4, 5, 6, 7 different minterms, and now the minimized function is this one. So if we are having any kind of, suppose we take another example, if we are having 3 variable or 4 variable function here, we are talking about 4 variables here. Again, it is minterm form. Suppose the value is 0, 1, 3, 5 only. See, although it is only representing 0, 1, 3, 5, but we have to be careful about the variables used here. We are using 4 variables, A, B and C, D. So for 4 variables, again to power 4, it will be total number of 16 squares required. So your number of boxes are depending on the number of variables, not on the minterms being represented here. So again, we have to make K-map for 16 squares. So in this case, we will make 16 different boxes. 2 variables are AB, 2 variables are CD. So here we will write AB, this portion will be CD. It will be 0, 0, 0, 1, 1, 1 and 1, 0. It is 0, 0, 0, 1, 1, 1 and 1, 0. Now since this value is representing as 0, at this point all values are 0, so it is high. This is 1, it is already 1. This value is 0, 0, 1, 1, so it is 3. Now we have to see for 5, so it is 0, 1, 2, 3. This value is, so for 5, the binary representation is 0, 1, 0, 1. This is representation for 5, or you can say it is M5 representation, because 6 is represented as 0, 1, 1, 0 and 7 by value 0, 1, 1. So M6 and M7. So since we are having only 5 value here, we have to search for this location 0, 1. So 0, 1 is already here. Next is again 0, 1. So it is 0, 1 here. So this value is representing your M5. So either if you directly remember this thing, that is fine. And that is M0, M1, M2 and M3, 4, 5, 6, 7. Or you can also see the values based on the combinations of these numbers. So here AB, because we are making combination of AB, CD. So in this case, AB is 0, 1, AB is 0, 1, CD value is 0, 1, CD value is 0, 1. So it is representing M5. So at this location, we are getting 5. Now we have to make group of numbers. So here group of 4 is not possible. So we have to focus on group of 2 numbers. So here we can make one group. Again, this one is left. So we have to make one group with this. We have to make one group with this part. So we cannot make group of 3, group of 5, group of 7. We cannot make group of these part. Only we have to make in the order of 2 power 0 to power 1 to power 2, as we have discussed already. So now first for this 1 and 1 combination, we can see that for both the cases it is C dash D. So C dash D is common. Now A dash is common for both ones. So here it will be A dash. Now take this part. For both the ones, it is A dash B dash, because they are falling here. It is A dash B dash. Both ones are having common this value A dash B dash, and next this D part is common in both the parts. It will be A dash B dash, then it will be D part here. The last combination is this one. Again, it will be having simply a dash b dash, but for this case your c dash is common, so your c dash is common. So the final function which is being represented, it will be a dash c dash d plus a dash b dash d plus a dash b dash and c dash. So by this we have obtained the minimized function. So whenever we are having any function for variable representation using K-map, first we have to fix the values of minterm, and based on the given minterm value we can easily denote these values in the boxes.